welcome everybody. It's great to see so many. Great to see so many people here. The first part I want to talk about is the PVTN, which is initiated by MLA, which is a pasture variety trial network, fully funded by MLA, where they asked all of the seed companies to put in their varieties to be assessed across a range of environments. So there were 6 sites established from Tasmania to Wagga, 3 in Victoria, 1 at Casterton, 1 at Rosedale in Gippsland, and 1 in the northeast, which I can't remember exactly where that was, but Stewie Kemp had that one. They were established either in 2011 or 12. They've run for 3 years as dry matter harvest and persistence sites, and now we're hoping that they'll actually go on to have a couple of years of grazing on them as well. So in the first few years, there hasn't been any animals step foot on them, but unfortunately it's the only way you've got to get the dry matter stuff first as a first drafting gate, and then persistence after that. So I'll cover that sort of stuff with that site. We haven't got the last lot of herbage cuts and persistence data was done at the end of, in mid-May this year. So hopefully we haven't got any actual physical, statistically analysed data yet. That should all be on the MLA website by Christmas. Planning to work on by site, by species, by variety, by season. So we've tried very hard to make sure we got, even if it was 300 or 400 kilos in an autumn cut on some cultivars within the ryegrasses, for example, then they were all cut. So to give you a bit of an idea of a production curve, rather than saying, oh, we'll wait till everybody catches up to 2 tonne and we'll cut the lot, I've tried really hard to make sure we're cutting them in season, so we've got that seasonality stuff in the system. And I think that grazing component, I think, is going to be very useful. We'll find out who's got pants on then. So with new cultivars, really what we're trying to, a number of people sort of challenged me to say, well, is it worth sowing something? Can we go back? Look, I'm just giving up. I'm going to go back and sow Vic and Australian. Well, I think if you're doing that, there's some, I understand the frustration, because there certainly has been varieties that really haven't performed for us, but there are varieties in the system that will do a job. But also I think equally we need to know what we expect out of that variety and how we're going to manage it. So we'll talk about that a bit as well. But I'm sure I know we've got varieties that are persistent and productive. And also one of the other things is that some of them are extremely palatable. So under a set stock system, there's some real issues that we're actually killing that plant because the stock like it. So being able to look after that, managing for the plant a bit occasionally is pretty helpful. This is a site just between Casterton and Coleraine, which is a heritage site, or a seed mark site originally, where we'd had it sown for 3 years, and the 2012 sort of summer came through. We had 15 perennial ryegrass varieties. This is on black cracking soil, so it's not a light sand. We had 2 cocksfoots, 2 fescues and 1 phalaris in the site. After the 3 years, we managed to kill every perennial ryegrass that was on the site. So again, if just thinking about what has survived in your environment, how you've managed it, in some cases you might need to take, a species might not be suitable for a certain environment. So it's hard to, with people from all over Victoria and South Australia here today, it's very hard to give you what you can take home for yourself. But in this is an interest. We didn't let it set seed, and for those 3 years it was grazed over the summer, but only lightly. And they're the rows of Vic perennial that we lost a lot. Whereas the fescue and the phalaris have stood up. So you've done things fairly badly there. So this is this is another site where there was half a paddock sown to ryegrass at the top end of the paddock for a couple of different reasons, but it ended up being managed as one paddock. It was never split up. So it was set stocked, and this is its 4th autumn that you're looking at now. So that's taken in early May. There was a mid-season perennial ryegrass on this side, and that's Holdfast GT on the right-hand side. So after 3 years, we managed to there's a couple of things that, it really didn't get treated the best, and we've lost it through our management. Not necessarily that it's not that variety's fault, but if we had, it was set stocked over summer, it's growing points above ground, and there's crossbred ewes on there. They ate it. They killed it. Whereas the growing point of this is under the ground, unless and our crossbred ewes will do a bit of digging, but they can't get to the bottom of most of it. So again, it's about looking at how you're going to manage a plant and what's fair to expect of it. Saying that variety's no good, it's not its fault. It's our fault. We've managed it wrongly. Just gives you some photos of the MLA site at Casterton, which is on the Cornish family at Barnoolet. Just to give you a bit of an overview, it's sort of red gum hilltop country. At about 25 to 35 centimetres, you've got a buckshot layer and a heavy clay under that, with a loam on top. pH of 5 and calcium chloride once we'd limed it. Olsen P of 12, potassium of about 220 and a sulphur of 10. So, not souped up. And at the end of the trial, after 3 years of cut and carry, we've still only got an Olsen P of 14 there. So we deliberately tried to keep it as a sheep beef site, not if it was a dairy site, they would have wanted an Olsen P of 25 or 30. So it's been kept in reality for us. So just give you a little bit of a look at some of the plots. So this is the ryegrasses in the first year at establishment, and each year we've put out mesh transects where we've counted 12 metres of actual row, every 5 centimetres of presence or absence of a perennial plant. So in the data that you'll get from MLA, you'll be able to see how many plants we started with, and in all of our grasses we started north of 85%, even with the Phalaris and the Cocksfoots, and what they're back to now, or whether they're still holding at those sorts of levels. June 2013, so it really thickened up and going well, but that's what it looked like at the start of May last year. And a similar sort of look in some of these now. So we've got a real diverse range within our ryegrasses of what's got density and what hasn't. The Phalaris, June 2013. The Cocksfoots, a huge range in activity. So some are active, some are dormant. So some of these you can see there's not a lot left in some of these. The highly summer active ones have suffered. Another look this autumn, again, you can see that some of these are... And also the other really interesting thing in in all of the grasses, that early autumn feed, there's a big difference between some of our cultivars. So hopefully you'll be able to use that sort of data to be able to say, well, this is the feed curve I need. What can I grab out of this toolbox? The subclovers are probably the most diverse of everything we've looked at. Just a huge range in vigour, especially early vigour. Ross Ballard's also done some work from the weight showing there's huge differences in nitrogen fixation between our varieties, even though when you cut them open the nodules are pink. So we'd always been taught if you cut it open it's pink, everybody's happy. Well, that might be as low as 20% nitrogen fixation. So instead of getting our 25 kilos per tonne of subclover, we might only be getting 5. So there's... And the confounding thing with our subclovers is they've got to re-inoculate themselves every year. So they've got to find rhizobia, from that seed. We plant it inoculated, hopefully, but every year after that, it's got to do it itself. So some of our cultivars are much more promiscuous and are happy to pick up whatever rhizobium's about, and there are certainly families that are doing a much better job of that. So I think there's some really good work, dry matter by end fixation, that could be driven out of some of these trials. And again, from a point of view of productivity, that's last June. These two varieties here cut a bit over a tonne of dry matter on their first cut, leaving 1,500 behind, whereas this guy here cut less than 300. So that there's a big split in them. Just look at that site late October last year or mid-October last year, our early season varieties already senescing. Just gives you an overall view of the site. There's about a hectare worth of plots there, so we're really pleased to have had that for the time we've had it. Okay, so if we're looking at trying to get a species and a cultivar to persist for us, the first thing we've got to assume is that the basic nutrition is right. So, and macro and trace element nutrition, we may not be able to affect subsoil acidity, so therefore that'll be something you've got to then select for. Summer dormancy often has a big role in persistence. Plant structure, so a plant that's got its buds underground is a hell of a lot harder to kill than one that's got everything above ground. Some of our ryegrasses have got a different structure as well. Ability to store carbohydrate or energy reserve and how quickly they do that. There's a group of ryegrasses that appear to be doing that very well. So they respond, they're actually summer active, so they're counterintuitive. They're summer active, but they respond to a rain really quickly and they put energy back into themselves as well. So there's some really interesting stuff there. Rooting depth and being able to stay in moisture. So if a plant has a good rooting depth and has got a wick of moisture, it will keep its buds and tillers alive. If you go and cut those, they're not nutrient feeding roots, they're moisture feeding roots. So if you cut those ones low, if the profile's already dry and you cut the bottom ones out, you will physically kill. In a ryegrass plant in particular, and in Phalaris, you will actually kill the buds on the tillers. So getting that rooting depth. And the fact that persistence is very much a huge number of traits into one bucket. It's not just, we haven't got one DNA marker that says that's the spot, we've got to have that and we'll have persistence. It's like number of lambs weaned. There's a lot of traits that go towards that. So in this situation, talking to Reg Hill about that and a couple of papers he's written, when you look at the species, the varieties and the cultivars that are performing well long term, most of them have been through some sort of cycle of drought. It may not have been under grazing, but it's at least been under a mower where they've survived. So being able to get that information from the seed reseller or whoever you're working with, if they've been through that system, it makes a huge difference to how well they go. And as I discussed before, what management system are we putting into it? A bolt upright 8 aluminium tolerant Phalaris, which will survive subsoil acidity, it won't handle set stocking because they've had to work so hard to select a trait for aluminium tolerance, but the plant is bolt upright. They will eat the whole thing out. So it's going to be. So if you're in that situation, you need to be prepared to do that, or you'll lose it. In particular, in our ryegrasses, where we've got strong ryegrass areas, there's a lot of pest pressure there. When you go outside, so when you go to marginal ryegrass areas, you tend not to. The pests don't come with them. Does that make sense? Because they're generally not in that environment. So in our strong ryegrass areas, root aphid, stem weevil, all sorts of things are there. Rust pressures are all there. So you need to have plants that have got good levels of resistance for those. Our cocksfoots, again, and when we're talking about subspecies, so it's within that group. So Hispanic cocksfoots are generally more tolerant of and persistent than our glomeratus, which is another subspecies. A lot of our Phalaris and ryegrasses that have been selected from either North American or Mediterranean backgrounds, when you go back and look at their parentage, they tend to be more persistent through that system. And the other thing with our fescues is generally our winter active fescues are actually doing a better job than our summer active, simply because our summer actives are really trying to grow quite strongly when they're moisture limited. And you can see that at the Casterton side. I should have left a slide in. Our summer active fescues there have really suffered just due to not enough moisture over that summer period. Okay, so our cocksfoots, really, they're the main things that they work on. They can cope with a huge amount of dehydration. Phalaris doesn't, so it just loses its leaves and that's it. Whereas cocksfoots will cope with a lot of that. They're highly summer dormant, and with both cocksfoots and ryegrasses, seedling recruitment is another way of keeping. It's not the same plant, but it's a way of keeping a pasture going. And so they'll both recruit quite well. And so every third or fourth year allowing a paddock to go to seed can give you a real leg up on keeping density in those pastures. This is just a bit of a continuum of just giving you an idea of where various cocksfoots sit. So at this end we've got Upland, Sendos, Casbar. Steve Clark from the DEPI have also got 2 new cocksfoots that fit into this area there. They're not released yet, but are performing very well and have been in the PPS or up near the PPS work. Curry, I think it's at least 60 years old as a variety, but in a lot of environments it's still a very good plant. And if you look after it from a point of view of keeping a clover into that system, it'll do quite a good job. If you've got better rainfall, you can look at a lot of these more summer actives. Okay, so this is this is a Wrightson's trial site at Maryborough. Again, your Glomeratus here versus your Hispanic lines of cocksfoot. Just huge differences in persistence after a number of years. At Casterton, just look, we had Megataz and Uplands and a group of Phalaroses in together. There was just a whiff of moisture came through. The Megataz woke up, whereas the Uplands base just wasn't, just doesn't throw a leaf up, so it can't get damaged in that period. Again, this is the Maryborough data, just looking at percentage ground cover. We're not sure why Sendos perform so badly there, because it's the little brother and should actually be doing just as well as Uplands. But you can see there's a huge range in that really tough environment. There's summer actives like Cara and Porto and Tekapo, virtually non-existent. Okay, I'll put this slide into just to give people a bit of an idea as to how long it takes to get a variety to market. With some of our genetic markers and that sort of stuff, we're improving that length. But in a lot of cases where, with drought, for example, where we don't know where those markers are, and for grazing tolerance, we've got to put them through. They've actually got to be out in the field and have that pressure applied. So we can tighten it up a little bit, but we've still got to get that actual paddock data. So to get things like GT and AT out of 15 to 18 years from concept to commercial release of Richard Kovner's work. And I think what I'm trying to show here is that the stresses that affect persistence, we've got climate with a range of things, we've got soils. Really the only thing we can accommodate to, we can fix fertility, we can generally fix surface pH, but we can't fix subsurface pH. And we've got this whole grazing pressure here. How are we going to graze that paddock? We end up with a short year. We can't put everything in stock containment. We end up with issues there. We overgraze stuff. Also, in a mixed sward, you've got real differences in palatability and at different times. So if you've got three ryegrasses at 3 different maturities, which one's going to, so if you've got an early, mid and a late, which one's going to get the biggest flogging? The late. Yep, because it stays reproductive longer. So the other 2 go up and become stemmy, so the sheep start going around them, and then they just push into that late plant. Often your late one is also fairly erect, so sometimes it's our management that affects that plant. Pest and disease, depending on what we're looking at, and competition with whatever else has been sown in the paddock. So out of that whole machination, there's 2 things that Richard concentrated on. One was grazing tolerance, one was aluminium tolerance, and they're the 2 cultivars that came out of that, GT and AT. This photo just demonstrating how erect most of our winter type Phalaroses are. They're bolt upright. They don't cover the ground very well. They don't fill in spaces. They haven't got the ability to backfill, whereas Australian will, and so will GT. And also your difference in productivity through that winter period with Australian. So this is Holdfast and Holdfast GT. Holdfast itself doesn't mean that it was grazing tolerant. Holdfast was designed for better seed retention. So for the seed industry, they understood exactly what it was. When it got put on the market, a lot of people assumed Holdfast, that it was a grazing thing, but it wasn't. Okay, so GT is quite a different selection. They put it out and there was 7 years of grazing set stocked before they went out and actually then selected the plants out of that to go into the work. So they've had a lot of pressure on them before they've actually started to then. That was the self-selection, and then they've worked from there. Okay, so there was the progeny test phase across at least 3 sites. I think there was also some at Hamilton as well. And this just gives you a bit of an. This is the thing that I find really. It's very hard to find, but the parentage, like if we want to select a RAM or a U and we've got ASBVs with it, we can go back 5 generations and know what it was. But in a lot of cases with our plant varieties, we've got no idea who mum or dad were. But if we knew, I think that it would actually help sort a bit of stuff out to start with. So it just gives you and the other exciting thing with Phalaris is there's such a huge amount of opportunity within the Phalaris. Just the diversity of that population for us to do it. Our ryegrass is bumping along at slight improvements. GT's probably made a 25% lift in one variety. It's taken 20 years, but there's a huge lift there to get. Okay, this is just looking at basal frequencies under that initial grazing to confirm that GT was really doing what they wanted. So Australian at the bottom and GT at the top. And then also Richard was concerned that he hadn't kept dry matter production with it, so he'd selected very heavily for grazing tolerance. But in seedling densities are good. Second winter, and third autumn, GT is performing well, and it's doing that winter production thing where Australian isn't. So if we're saying we want persistence, but we also need winter production, we can say that we've now got that. Okay, so there was the trial. Once they've done that, we're looking at a group of populations with high and low fertility, set stocked versus rotational at a high fertility level and a low fertility level. I wish it'd sort of been something in the middle at sort of 12, but there wasn't. So at set stocked with high P, what we're looking at here, the Holdfast GT has really held its own very well. When we're looking at things like Landmaster and Serosa, we've certainly dropped out our basal frequency, so that's the percentage of ground cover that we've been able to keep. Holdfast is happily keeping sort of 60 or 70% of that ground cover. And this probably is illustrating that slide is now what you're seeing in a visual picture, and you've got Holdfast GT there compared to Australian, so virtually the same densities. Holdfast itself not standing up, neither's Landmaster in a set stock situation. So if we rotationally graze it, so if we've got a paddock of Serosa, for example, and there's still good plant density there, to keep it that way, we need to rotationally graze it. Okay. And the set stocked ones show at lower P show a fairly similar situation, and we've still lost. Our Holdfast GT is underneath Australian, but still in the same ballpark. But the lower the fertility, the lower total plant numbers. So what we've had there is it's about amount of carbohydrate that plant's been able to achieve. So just taking through here there's a pasture paddock locally, just looking at Holdfast GT structure, and as I said, Serosa stands bolt upright, GT is quite prostrate, and just showing that we've got young buds and tillers out quite a way around that plant and its ability to actually fill in an area. And when you look at in the MLA site, you look at GT and you look at Australian, you've got no hope of telling where one plant started and the other ended now. They're just one continuum. And so from a soil acidity point of view, I think most people understand we've got we've got topsoil issues, but we've also got quite a bit of subsoil issue in the northeast and through southern New South Wales, where we're just never going to get, we can't, on huge areas, we can't get lime down to 20 and 30 centimetres. So the plant breeding has worked on trying to get cultivars that will tolerate aluminium. So this slide is a nutrient solution, but on your right there is AT, which ended up being the new cultivar, being able to tolerate 50% aluminium in solution. So huge, as a percentage of the cation exchange, being able to tolerate that amount of aluminium at depth is just amazing. And so this is just one photo demonstrating the topsoil pH of 3.9 and 26% aluminium, and underneath that, virtually the same pH but 35% aluminium. So you've got advanced AT there. Pretty happy with the world, and Serosa, lost well and truly. Just a slide showing of another trial we had at Casterton, just showing that Holdfast GT has performed. Serosa is highly productive as well, don't get me wrong, but it won't tolerate the grazing against uplands and megatas. And what we also have got in some of our ryegrasses, we've got some of these Spanish types that are actually reasonably summer active, which is a bit odd, but are persisting quite well, versus some of our others that are coming through that aren't. So for Phalaris management, really, or for new cultivars, we're really looking at that. They don't need any different management fertility-wise. If you're going to grazing management, GT can be set stock for big amounts of time. AT really needs to be rotationally grazed. So in summary, we have got a number of new cultivars that are extremely productive for us. They're highly palatable, which does create a risk, so you've got to know how to manage them in a lot of cases. PVTN trials and other trials that have had a good focus on plant persistence and hopefully some grazing really gives us a much better guide as to what's going to persist for us. And if the data isn't under our environment, then I'd really be quite careful of it. Okay, and just in closing, I'd like to thank James Sewell from Wrightson's, Richard Colviner from CSIRO, Reg Hill, who's now retired, both DPI and Wrightson's, Stuart Smith from Tasmania, Tim Pepper from Heritage, and my Best Will Best Lamb group for being prepared to share a lot of this data. So we've put most of what's there, some's mine, some's Tim's. So, it's a combination, but it's great to have that honesty to be able to get all that information out into the public forum. Thank you.